Xabier Couto introduced neural networks and ran through how they worked. Then the students were given pre-calculated examples to explore.
The main goal of my talk was to explain the fundamentals and the basics of the neural networks, in the sense that they are a black box machine learning. A lot of people use them, and it's quite important to me to understand the mathematical foundations behind them. One of the machine learning tools that we have used the most with Gaia data are neural networks. The inspiration of neural networks come from the biology to simulate the human neuron with a structure called the perceptron. What the perceptron does is to get some inputs that are these x, multiply them by some weights, w, that we want to tune, to train. So the main advantage of the perceptrons is to combine them in multiple layers. And we train the network by comparing the outputs with the labels of our data set. Okay? First steps of any machine learning algorithm, that is just to compute the difference between the true value and the predicted value, do the square and then the mean for all of the instances. So this curve is the parameter space of the loss function. If we want to find the optimum, that is the weights that reduces the loss, and see in which direction the loss function will be reduced. Okay? Yeah, the best way to work with that is to play around with neural networks and to try the best hyperparameters for your problem. So I propose you to go to one of the most used libraries in Python to code neural networks, and they have an online tool that is this playground that allows you to build a neural network and to see how the results change. Okay? Now we can prove that any function can be approximate with a neural network with enough number of hidden layers. However, that's also the main drawback of the neural networks, that they have two hyperparameters to tune, and it's a bit frustrating when you are building a neural network and you realize that you have been the last 4 weeks just tuning, changing the numbers, tuning the parameters of the network, changing the number of hidden layers, the number of neurons per layer, the regularization, the learning parameter, the optimization, etc. Just to improve your result by 1%. So I think that this is the most frustrating and the most difficult also to work with neural networks.